My dear students, we are discussing moving charges and magnetism. Up to part 6, we understood a stood experiment with that moving charges produces magnetism, and we understood a magnetic field and a magnetic force and Lorentz force. Okay, with these questions, I am going to revise previous concepts. Carefully listen and try to understand, and don't skip any part. You should watch all the parts and try to understand the complete lesson and read textbook each and every sentence and what assignments I'm sending. Okay, you completely do that assignments. If you have any doubts, you can see once again. You can see my video. You can understand easily. Okay, still you are not understanding means after college definitely can clarify your doubts. Okay, please put effort. Don't waste your time. Definitely can get good marks in the future. Each and everyone you can score good marks. Listen carefully. Okay, question number 1 up to part 6. Okay, part 6 concept this one. Lorentz force, right? On what factors Lorentz force depends? In board exam for 3 marks this question they will ask. On what factors Lorentz force depends? Okay, if you remember the formula, then easily on what factors Lorentz force depends, easily we can write. Okay, Lorentz force. Lorentz force formula is what? Lorentz force is nothing but what? Force experienced by charged particle in electric and magnetic field is called as what? Lorentz force. Okay, nothing but sum of the electric and magnetic force. What is the electric force? Okay, E bar into Q. E bar into Q is called electric force. What is the magnetic force? Q into V bar cross V bar. Okay, if you remember this expression, right, this is the expression for Lorentz force. What is the expression for Lorentz force? Okay, E bar into Q plus Q into V bar cross V bar. This is a expression for Lorentz. What is the Lorentz force? Force experienced by charged particle in electric and magnetic field is called a Lorentz force. Okay, sum of the electric force and magnetic force. Right, E bar into Q plus Q into V bar cross V bar. Okay, now tell me what is E bar here? Electric field. What is a Q? Charge. What is a V bar? Velocity of charged particle. What is a V bar? Magnetic field. Okay, then on what factors this force experienced by charged particle in a magnetic field depends? Okay, or on what factors does Lorentz force depends? Okay, the factors depends upon Lorentz force. Or what? First is your E bar, electric field. Electric field changes. Okay, Lorentz force changes. And charge of the particle. Charge of the particle changes. Lorentz force changes. And V bar, velocity of the particle changes. Lorentz force changes. B bar, magnetic field changes. Lorentz force changes. And the angle between velocity of the charged particle magnetic field changes. Lorentz force changes. If theta is equal to 0 here, how much this one? 0. Theta is equal to 90 is a maximum. Right? Theta 90 maximum magnetic force, then maximum Lorentz force here. Okay, and Lorentz force, right? It is what? Depends upon electric field and depends upon the velocity, magnetic field and charge of the particle. Okay, in an electric field, it is independent upon the electric field. It depends upon the magnetic force. Okay, so generally Lorentz force depends upon what? Electric field, charge of the particle and okay, velocity of charged particle, magnetic field and angle between the velocity of charged particle and magnetic field. In an electric field, does not depend. If electric field is constant, okay, it depends upon what? These factors. Okay, I hope you understand, right? So F bar is equal to E bar into Q plus Q into V bar cross V bar. Lorentz force depends upon electric field, charge, velocity of charged particle, magnetic field and angle between the velocity of charged particle and magnetic field. And this is expression for what is a vector form of Lorentz force. This is a vector form of what? Lorentz force. F bar is equal to E bar into Q plus Q into V bar plus V bar. On what factors magnetic force depends? Q into V bar plus V bar. Magnetic force depends upon what? Charge, velocity of charged particle, magnetic field and angle between the velocity of charged particle and magnetic field. Okay, second question. So this is last for 1 mark in a board exam. A proton enters a magnetic field at 30 degree. Okay, what given there? Theta is 30 degree, angle given. Okay, at what angle should it enter to experience a double the force? Let us consider theta 130 degree. F1 is equal to F and Q1 is equal to Q2 is equal to Q, same charge. Okay, but force is what here? Double. At what angle? Force is what? Double. At what angle? Theta is a question mark. Okay, we know that F2 by F1, right? F2 by F1. F magnetic force acting on charged particle formula is what? QVB sin theta. QVB2 or same magnetic field B sin theta 2. Okay, and F1 is what? QVB sin theta 1. Q get cancel, VV get cancel, VV get cancel. So F2 here, F2 how much here? 2F. F1 how much here? F is equal to sin theta 2. So we are going to calculate theta 2 sin theta 2 by sin theta 1. How much it is theta 1? How much given? 30 degree. That implies. Okay. F get cancel. Sin theta 2. Sin theta 2 is equal to sin 30 1 by 2 into 2. 2 to get cancelled. 1 means sin 90. Sin 90. Then what angle? Sin theta 2 is equal to sin 90 means theta 2 how much? Students? 90 degree. Right? Theta 2 is equal to how much? 90 degree. This answer is enough in a board exam. If they ask for 1 mark, just write 90 degree. A proton enters a magnetic field at 30 degree. Right? 90 degree. Okay, 90 degree angle. If it is a charged particle, this proton is enter perpendicular to the magnetic field or 90 degree with the magnetic field. Okay, so it experiences how much force? Double the force. Okay, understood. Right. Question number 3. Find the magnitude of the force experienced by electron moving with a velocity 0.5 in 10 power 7 meter per second in a magnetic field of strength 0.5 in 10 power minus 2 Tesla, making an angle 30 degree with the magnetic field. Meter per second, what is given? Magnitude of velocity given. Tesla, what is given? Magnitude of magnetic field strength. 30 degree, what is given? Angle between velocity of charged particle and magnetic field. Then, so what is the solution for this? We know that magnetic force acting on charged particle formula is what? QVB sin theta. Substitute values. What is the Q here? Charge of the particle. Which charge particle here? Find the magnitude of the force experienced by electron. Electron. Okay. What is the charge of electron? Charge of electron is 1.6 into 10 power minus 19 coulomb. Okay. Why I am not writing minus here? We are calculating magnitude of magnetic force. That's why I am not writing here minus. Okay. So this is what magnitude of charge of electron. 1.6 into 10 power minus 19. All magnitudes I am taking. Magnitude of velocity. Okay. 0.5 into 10 power 7 meter per second. And magnetic field 0.5 into 10 power minus 2 into theta 30 degree sin 30. Okay, all values are substituted. Q, V, B sin 30. Simplify this one. 16 5s are 18, 80 5s are 400. 400 into so 10 power minus 1, 10 power minus 1, 10 power minus 1. 10 power minus 3, 10 power minus 3, 10 power minus 90, 10 power minus 22, 10 power minus 22, 10 power minus 2, 10 power minus 24, 10 power minus 24, 10 power 7. So which is what? 10 power minus 17 into sin 30 how much? 1 by 2. This is a 200 into 10 power minus 17 Newton. Or else we can write 2 into 200 we can write what? 2 into 10 square. Okay, 2 into 10 square in 10 power minus 70 means 2 into 10 power minus 15 Newton. This is important for 2 marks. Just to write the formula, substitute values and simplify it. You will get a magnetic force on charged particle. How much it is? 2 into 10 power minus 15 Newton. Okay, so magnetic force. Here are what? Find the electric field information not given. Only magnetic field information given. Find the magnitude of the force experienced by an electron moving with a velocity in a magnetic field. Then, okay, magnetic force acting. Okay, then Q will be sin theta. In Lagrange force, sometimes they will ask what is how much Lagrange force acting on. That time, electric force information also will give. Then what is the total force experienced by charged particle in uniform magnetic field? That time, so some of the electric force and magnetic force you can take. But here only magnetic field information given. Then what is the force experienced by electron in a uniform magnetic field? That is Fm is equal to Q will be sin theta. Q is what? Here magnitude of charge of electron, that is 1.6 in 10 power minus 19, and magnitude of velocity is what? 0.5 in 10 power 7 And magnetic field is how much here? 0.5 in 10 power minus 2 and sine 30, right? So 16 5s are 80, 80 5s are 400, 10 power minus 1, 10 power minus 1, 10 power minus 1, 10 power minus 3, 10 power minus 3, 10 power minus 19, 10 power minus 22, 10 power minus 22, 10 power minus 2, 10 power minus 24, 10 power minus 24, 10 power 7, 10 power minus 17 into sine 30 value 1 by 2. Simplify it, you will get 210 power minus 17 or else 2 into 10 power minus 15 Newton. This much force experienced by electron in this magnetic field which is moving with velocity how much? 0.5 10 power 7 meter per second. And what is the angle between the velocity charge particle and magnetic field? 30 degree. Okay, my dear students, up to part 6, what we understood, force experienced by charge particle in a uniform magnetic field. Now today, so we are going to understand magnetic force on a current carrying conductor. Magnetic force on a current carrying conductor. Okay, so let us consider this I current is flowing through this conductor. This is a current carrying conductor. I current is flowing from here to here. Opposite direction of this current which is moving, electrons are moving. With what velocity? Vd velocity. Vd is nothing but here drift velocity. Means electrons are moving in a uniform magnetic field. This due to this flow of electron, what happened? Current is flowing in the conductor. Current is flowing through the conductor means what happened? There is a flow of electron. There is a flow of charge. Okay, the charge is moving in a magnetic field. When charge is moving in a magnetic field, what happened? Force experience. It experiences a force. Already we understood. When the charge particle is moving in a magnetic field, it experiences force. Okay, that force is what? Q into V bar cross V bar. Okay, now let us consider L length of the conductor, L length of the current carrying conductor, which is placed in uniform magnetic field. Okay, how it is placed? It is placed theta angle with the magnetic field. Okay, the magnetic force on each electron means in this conductor not only one electron, many number of electrons. Okay, then the magnetic force on each electron how much? The magnetic force on each charge particle in uniform magnetic field how much? That is Q into V bar cross V bar. What is the Q here? Q is minus C. What is the Q here? Minus C. Charge of the electron negative minus C into Vd bar cross V bar. Q into V bar cross V bar. This is minus C is what? Charge of the electron into Vd bar cross V bar. This is a magnetic force on each electron. Magnetic force on each electron is minus E into Vd bar cross V bar. Since we know that, so force, magnetic force acting on charge particle formula is what? Q into Vd bar cross V bar cross V bar. General expression, magnetic force acting on charge particle. The charge particle is moving in a uniform magnetic field. Force experienced by charge particle is what? Fm bar is equal to Q into V bar cross V bar. Okay, right. So here the magnetic force on each electron charge how much here? Charge of the electron is how much here? Minus C. And what is the velocity of the electron here? Drift velocity. Okay, velocity, average velocity acquired by the electron in a conductor. That is called as what? Drift velocity. Vd bar. Okay, cross B bar. Okay, B bar is a external uniform magnetic field. This is a magnetic force on each electron. Next, total force on the electrons. Okay, then each electron this much force acting means, right? The total force acting on, the total force on the electrons. Total force on the electrons is what? Total number of free electrons. Okay, total number of free electrons into force on each electron. Okay, for that you should calculate what the total number of free electrons. Force on each electron we know. Now we are going to understand what is total number of free electrons. For a conductor, given a conductor, electron density means what? Number of electrons per unit volume. Number of electrons per unit volume is called electron density. Okay, electron density, number of, this capital is what? Number of electrons per unit volume is called as electron density. Okay, for given a conductor that is constant. Right? Now A is area of cross section, L is the length of the conductor. This is what? Total volume of the given conductor. area of cross section, length, means total volume of the conductor. In this volume, how many number of electrons are there? This capital N represents what? Total number of electrons. AL represents what? Total volume of the conductor. Then total how many number of free electrons the conductor, given conductor? Capital N is equal to electron density into AL. Okay, suppose 1 unit volume, how many number of electrons? Small n. 2 unit volume, how many number of electrons? 2n. 3 unit volume, how many number of electrons? 3n. 4 unit volume, how many number of electrons? 4n. AL volume, A is area of cross section, L is length of the conductor. AL volume of the conductor, how many number of free electrons? N into AL. Okay, the number of free electrons in a given conductor is small n into A into L. N is a electron density, number of electrons per into volume. This is constant. Okay, AL is what? Volume of the given conductor. Okay, in this volume, how many number of electrons? Electron density into volume. Right? Now write the expression total force on the electrons. Total force on the electrons is what? Total number of free electrons. Total number of free electrons what? N into A into L. This is the total number of free electrons into force on each electron is what? Minus E into Vd bar cross B bar. Correct? Na? Right? So total volume is in total number of electrons. How many number of electrons in the given conductor? N into A into L into minus E into Vd bar cross B bar. Right? Still simplify this expression. You will get what? Okay. So L is here vector quantity, length. Vd bar also drift velocity, vector quantity. Just interchange this one. What will you get? N, A and E. Okay. Minus sign is here. Minus sign. Minus N, A, E, Vd into L bar cross P bar. What is the L bar direction here? L bar direction is nothing but along the current direction. Along the current direction is a L bar direction. Means this L bar direction is what? Opposite direction to the electron. Once again I am telling. Length of the conductor is what? Along the direction of current. Current direction is what? Opposite direction of electron. That's why here length of the conductor direction and electron direction, drift velocity direction, both are in a opposite. Both are in a opposite. That's why I am writing here both are in opposite direction. Okay, I can write the total force acting on. So total force acting on current carrying conductor in uniform magnetic field F is equal to, okay, NAEVD. NAEVD in a current electricity. I hope you understood drift velocity. What is the drift velocity? Vd is equal to I by NEA. Then I is equal to what? Vd NEA. Vd NEA nothing but current in a conductor. Instead of Vd NE, what we should write? Current in the conductor. How we written? From drift velocity definition. This is where you learned in a current electricity. That is what Vd is equal to what? I by NEA. Okay? Then I is equal to what? Vd NEA. Remember this very important formula in current electricity. Vd is equal to I by NEA. I is equal to Vd NEA. Understand? You understand? Today you learned one new important formula, right? So remember this one. What is the formula? Drift velocity. Drift velocity Vd is equal to I by NEA. I is equal to Vd NEA. Okay. Instead of NEA Vd, you write a I. Then what will you get? Minus I L bar cross B bar. What is minus sign here? Minus sign here, direction of length, direction of drift velocity, both are in opposite direction. Once again I am telling, minus sign tells that what? Direction of length, direction of drift velocity, both are in opposite direction. Then, okay, so here I am writing F bar is equal to, okay, F bar is equal to, if you remove this direction, okay, magnitude of F bar, or simply we can write F bar is equal to I into L bar cross B bar. Minus tells nature. What nature? Which nature it is? Direction of current, direction of drift velocity. Both are opposite. What is the minus sign here? Direction of current, direction of drift velocity, both are in opposite. That minus sign tells. Okay, that's why the force acting, that minus tells only nature, the minus sign tells the nature. What is the nature? Okay, drift velocity, and that the minus sign tells the direction. Okay, what is the direction? Okay, that is direction of length of the conductor along the current direction, which is a opposite direction to drift velocity. Opposite, minus is nothing but here opposite direction. Length of the conductor is opposite to the drift velocity of the electron. Then force acting on the current carrying, total force acting on the current carrying conductor is what? I into L bar cross B bar. Okay, this has a magnitude and direction. You know, A bar cross B bar. A bar cross B bar nothing but AB sin theta. L bar cross B bar nothing but LB sin theta. Then we can write this one, I into LB sin theta. A bar cross B bar is AB sin theta. L bar cross B bar is what? LB sin theta. I is what? Current flowing through the conductor. L is magnitude of length of the conductor. B is what here? Magnitude of magnetic field. Theta is what here? Angle between the length of the conductor and magnetic field. Correct? Then, so direction, okay, force direction I am writing here, n cap. What is the direction of force? Direction of L bar cross B bar. Direction of force here, L bar cross B bar direction is the direction of force. In a Fm bar is equal to Q into V bar cross B bar. What is the direction of force? V bar cross B bar direction. Already we understood that one. Here, what is the direction of this force? Direction of this force is what? L bar cross B bar direction. How to determine this direction of force? By using which rule? Already we understood. 2-3 times we discussed. Okay, we understood that one. Okay, direction of force, direction of magnetic force. Okay, by using which rule? Right hand rule, or else Fleming left hand rule. Okay, na? Right hand rule, by using right hand rule or Fleming left hand rule, we can determine the direction of force. Okay, it is a current carrying conductor. Understand? So which is placed in a magnetic field. Then how to determine the direction of force acting on it? Okay, I hope you understand the direction of force. Correct? Na? Right? You can apply Fleming left hand rule also. Easy it is. Current carrying conductor. Right? So it is your left hand. Stretch first 3 fingers of the left hand mutually perpendicular to each other. Stretch known one which is current direction, you know, magnetic field, you know. Okay. Now it is a magnetic field. 4 finger represent the direction of magnetic field. Central finger represent direction of current. Direction of current means this is the direction of current. This is the direction of magnetic field. This is what? Direction of force acting on conductor. It is what? Towards you. Means it is away from the board. Correct? Na? Then force acting on the current carrying conductor is what? Away from the board, perpendicular and away from the board. This force is perpendicular to the plane containing L bar and B bar. Okay, direction of force which is perpendicular to the plane containing this board is a plane. This force direction is what? Perpendicular to the plane. Means which is perpendicular to L bar. Okay, L bar is current direction. Okay, L bar and B bar. I hope you understood direction of force. So direction of force is what? Direction of L bar cross B bar. Right, here also if theta changes means, okay, theta changes means magnetic force acting on the current carrying conductor also changes. Okay, first I am going to revise this one. Magnetic force on a current carrying conductor. The magnetic force on each electron, you know. Okay, a current carrying conductor which is placed in uniform magnetic field and which is placed what? Theta angle with the magnetic field. Let L bar is length of the conductor, A is area of cross section, AL is volume of the conductor. So, then N is small n is your electron density, capital N is what? Small n into AL. This is total number of electrons in a conductor. Right? First we are calculating what? The magnetic force on each electron. F bar is equal minus C into VD bar cross B bar. How written this one? We know the formula. Force experienced by charge particle in uniform magnetic field. Fm bar is equal to Q into V bar cross B bar. Total force on the electrons, nothing but total number of free electrons into force on each electron. Total number of free electrons, how we calculated, how we understood. Okay, this is the electron density. Electron density means number of total number of electrons per unit volume. Right. So in this volume, how many number of electrons? Okay, capital N is equal to N capital N is the number of free electrons in the conductor. N into A into L. Then in current electricity, okay, we understood VD, drift velocity of the electron in a conductor. I by NEA. From this I is equal to VD NEA. Okay. Now all the values substitute here. NEAL into minus E into VD bar cross B bar. Then minus NEAE VD into L bar cross B bar. Right? NEAL E VD written outside, L bar written inside, L bar cross B bar. Then F bar is equal to what? instead of this NEAUED, I into L bar plus B bar. Right, minus sign tells what? Direction. Which direction? Current direction and drift velocity of electron. Length of the conductor and drift velocity both are in what? Opposite direction. Okay, this tells the direction. Then F bar is equal to direction of only that tells the nature. Okay, current direction and which one? Drift velocity both are in opposite. Okay, then a force acting on total force acting on a current conductor which is placed in uniform magnetic field is what? I into L bar cross B bar, or else A bar cross B bar means AB sin theta, L bar cross B bar means what? LB sin theta. I into LB sin theta into N cap. N cap is nothing but direction of force. The direction of force is okay, same as what? Direction of L bar cross B bar. How we are going to determine the direction of force? By using right hand rule or else Fleming left hand rule. Okay. Now, if theta changes, force on charge particle, force on current carrying conductor also changes. If theta is equal to 0, okay, if theta is equal to 0, nothing but how it is placed there? Current carrying conductor which is placed parallel to the magnetic field. Then what is the force acting on it? Theta 0 means sin 0, 0. Then in this case, what is the magnetic force acting on it? 0. Okay, if theta is 180, current carrying, so in this direction, current along the direction of magnetic field, current is flowing nothing but, okay, that is parallel to the magnetic field. Okay, opposite direction of magnetic field, current is flowing nothing but anti-parallel. In that case, theta is equal to 180. Theta is equal to 180. If theta is equal to 180 degree, right, sin 180. Sin 180 how much? 0. Then in that case also, what is the magnetic force acting on the conductor? 0. Right? So theta is 180 degree. Then also magnetic force acting on the conductor is what? 0. Then when which case it is maximum? Theta how much it is, students? Tell me. Okay, at what angle between velocity of charge particle magnetic field, force acting on a force experienced by charge particle in uniform magnetic field is maximum? Theta 90, correct na? Then Fm is equal to QVB, right? Maximum force acting on charge particle in uniform magnetic field is what? QVB. At what angle theta is equal to 90? Here, so if theta is equal to 90, theta is equal to 90 degree, then what is that? The maximum force acting on current carrying conductor is what? Bill. What is that? Bill. Remember, simplified manner what? Bill. Okay, B is the magnitude of magnetic field, I is the current carrying conductor, L is the length of the conductor. Okay, I hope understood what? Force, a magnetic force on a current carrying conductor. What is that? Magnetic force on a current carrying conductor. Clear now? Okay, dear student, just now we understood magnetic force on a current carrying straight conductor. What is that formula? Magnetic force on a current carrying straight conductor. What is that? Fm is equal to Bill sin theta, correct na? So Bill sin theta. Bill sin theta. Okay, we understood theta is equal to 0. Sin 0 is 0. Then in this case, what happened? Magnetic force is equal to 0. Theta is equal to 180. Then sin 180 also how much? 0. Then magnetic force how much? 0. If theta is equal to 90, okay, what is the theta? Angle between the length of the conductor and magnetic field. If theta is equal to 90 degree, sin 90, which is what? 1. Then magnetic force how much here? B. Okay, so it is a maximum force acting on a current carrying conductor. Okay, what is the angle between the length of the conductor and magnetic field? Okay, then the magnetic force acting on conductor is maximum. Fm is equal to, okay, Bill, when it is sin 90 is equal to 1, means theta is equal to how much here? 9. It is a straight conductor case. It is what? A straight conductor case. Suppose given conductor is what? Arbitrary shape. Means any shape, not straight conductor. Arbitrary means any shape it is. In that case, how we can calculate a magnetic force on a current carrying conductor? For that, given conductor, you divide infinitesimally. Okay, small elements you can divide. D element here, 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 D. Like that, infinitesimally you can divide the elements. Now, force acting on this element how much? Force acting on this element how much? Force acting on this element, this element, this element, this element, this element, this element. Like that, force acting on individual elements you calculate. That is what? dF. The dF is what? I into dl bar cross b bar. Suppose I current is flowing through a conductor. Okay, right? Then the total force means apply the integration or add all the forces. Okay, here force, here force, here force, here force, here force, here force, all forces you can add. Then you get the total magnetic force acting on current carrying conductor is what? Sigma I dl bar cross p. Okay.